Guys, in this video we are going to talk about continuous and discrete time signals. Continuous time signal is a signal that is specified for every value of time, and discrete time signal is the signal that is specified at discrete time intervals. The continuous time signal is given by x of t, okay, x of t, and discrete time signal is given by x of n. Okay, here x is the dependent variable and t is the independent variable, and here x is dependent variable but n is integer. Okay, now let's look at some example. Let's look at an example for continuous time signal. If we draw a graph for a continuous time signal, we are going to have y-axis and also we are going to have x-axis. In the y-axis we will have the function or signal, that's x of t, and in the x-axis we will have the independent variable, that is time. Okay, and this will be continuous from negative infinity to positive infinity. So this, if this is t, here we are going to have negative t. So this is from negative infinity to positive infinity. We will have graph. Let's draw with a different color. So from here to here, let's say it's ending here and inclining right here, going until this, and then declining right here and going until positive infinity. So it's going from negative infinity to positive infinity. Here you can see this is continuous everywhere. That is why we call this continuous time signal. Okay, and discrete time signal, if we pick up some time intervals, like let's say this is t1, this is t negative 1, and let's say this is t negative 2, t2, and t3, t negative 3. And if we draw this part alone for here, okay, x-axis, like y-axis, and here we are going to have x-axis, and then here we are going to have the time and x of n, and here for t1, let's draw with a different color. For t1, let's call this one a. So for when the time 0, t0, at t0 we have a. Okay, at t0 we have a, and t1 we have this one. Here we have t negative 1, we have this one, and at t negative 2 is 0, and here 0, 0, it goes like that, right? Okay, so this is t negative 1, this is t negative 2, t negative t2, t3, t negative 3, and here you can see here the signal is specified at discrete time intervals. It's not continuous everywhere, right? In between t to t negative 1, you don't know what's the time is, right? So that's why we call this one discrete time signals. And that is it for this one. And here we can say delta t. This may or may not be t1 minus t0, like it may or may not be equal everywhere. Like sometime we will have equal t1 minus t0, that will be equal to t2 minus t1, that will be equal to t3 minus t2, that will be equal to t, if we say the final part is tn, and tn minus 1. So this may or may not be equal. If this is equal, we call this one uniformly sampled. If it's not equal, we call this one non-uniformly sampled, right? So let's say we have delta t, that is equal to t. If this is uniformly sampled, we have to make this one 0, and if this is 0, here we are going to have, here we are going to see how did, because here we have x of n is the integer, but for the x-axis we have t. So if this is x of n, we cannot have t, right? So we are going to see how we are going to derive n right here. We are going to see how did we derive that one. So if this is 0, this is going to be t, because delta t is t. If delta t is t, we are going to have t1 minus t0 is going to be t, then t2 minus t1 also going to be t. So if this is t, we are going to have 2t right here. This is going to be 3t, and it goes like that, right? So instead of xn, we have to write xn of t. If this is xn of t, x of nt, then here we have to have 1, 2, 3, right? 1, 2, 3, 4. So 1, 2, 3, 4. Then if this is 1, 2, 3, 4, then this is going to be n. And if this is n, then we get rid of this t. So x of n times n, like x of n, n. This is the graph of discrete time signals. Okay, those are some basic stuff about continuous and discrete time signals. Now let's look at a problem. Let's say we have a problem. Let's draw a graph. Okay, let's say we have a problem like this, and we want to express the interval. Okay, here let's say we have some amplitudes 2. Okay, this is 0, this is 1. So this is 1, 0. Let's say this is also 1 and 1 right here, and this is 2, 2, 1. And here we are going to see how to express this one. -1, 0, 1, 2, 3. Okay, to express this one, what we do is we put x, and in the curly bracket we put n. Okay, and then we write the amplitudes. 1, 0, 1 is the amplitude, 0, 1, 2, 2, 1. So we write in this order: 1, 0, 2, actually 1, right after this 1, 1, 0, 1, 2, 2, 1. So this is how we express, but this is not like this only not enough, because we don't know if this is the only information we have. We don't know where it is located, like we don't know the independent variable, right? So to express independent variable, like for example, if you say this is, you made a mistake, like if you just say -3, then this is going to become -2, this is going to become -1, this is going to become 0, and this is going to become 1, this is going to become 2. Then you can see this entire graph is shifted. Entire graph is shifted 1 unit, like it's 1 unit difference, right? Like this is more to the 1 unit. So that's not a correct representation. So to represent this one clearly, what we do is we look at the amplitude at 0. Here we have amplitude 1 at 0. So we look at the amplitude at 0 and we point that amplitude, like we point this one, and here we say x of n when n is equal to 0. So this is the correct representation of this graph, and those are some basic stuff about continuous and discrete time signals. I hope this helps. Thanks for watching.